everybody who's watching this video. This is the video for section 1.3 and 1.4. 1.4 is on the back side of this notes page. We're going to do both of them together because they are fairly easy sections, but this is kind of a long section after we do both of them together, okay? So 1.3, I cut down the homework assignment. It used to be 10 through 34, the evens on both of them, right? But I crossed that off and we're only doing those problems on 1.3 and those problems on 1.4. So get those written down. It's also up on my board over here. So there you go. All right, 1.3, rate of change and slope. Those two terms are used interchangeably. Rate of change is asking for the slope and vice versa. Okay, they mean exactly the same thing. The slope or the rate of change is the rise over the run. Have you heard that before?
Yes.
Rise over run, rate of change, rise over run, okay? Now, which variable, x or y, talks about the rise? Which one is the rise, the one that goes up and down? The y is the rise, okay? The run, or the left and right, is the x's, right? So that's why it's the change in y over the change in x's. Make sense?
Yes.
Good? Okay, they give us example 1. It says the table over here shows the temperature of a solution after it's been removed from a heat source. So you heat this beaker up and then you take it off the heat, and what's going to happen to it?
It's going to cool down.
It's going to start to cool down. Cool down, cool down, cool down, cool down. Okay? Find the rate of change. What's that mean again?
The rise over run.
The slope, the rise over run, in the temperature of the solution. Okay? So basically we're looking at the y variables, which is always the second one, over the x's, which is the time, right? The y is the temperature, the time is the x's, okay? All right, so let's do this over here. We're looking at it going from 143.6 degrees to 139.4. So if we subtract those two, 143.6 minus 139.4, what does that give you? 4.2.
Yeah.
Okay, but it has gone down 4.2 in a matter of how many minutes?
2.
2 minutes, right? You see that?
Yes.
Okay, if I take negative 4.2 and divide by 2, that is a slope of negative 2.1, right? If we reduce. Okay, now we're going to do the next one. Going from 139.4 to 133.1, how many am I going down?
6.3.
I'm going down a minus 6.3 in a matter of how many minutes from 2 to 5? 3 minutes, which is, if I divide, negative 2.1. Okay, the next one, I'm going to use a different color. From 133.1 degrees to 126.8. How many is that?
8.4.
Negative 6.3. In a matter of from 5 to 8, that is another 3 minutes. So that's an average of negative 2.1. Okay, and the last one, it's going from 126.8 to 118.4. That is going down 8.4 this time, but it's in a matter of 4 minutes instead of 3, right?
So it's negative 4.2.
So negative 8.4 divided by 4 is negative 2.1. Okay, so the slope is, or the rate of change is, negative 2.1. Now what does that mean?
That's the run. No, it's not.
What is negative? How do you interpret negative 2.1? It means what? What?
The rate change.
That's exactly right. It drops 2.1 degrees per minute. That's exactly what it means. On average, it is dropping a rate of 2.1 degrees per minute.
So,
That is the rate of change. It is the slope.
Okay, I'm good.
Okay, good? That's exactly what that means, all right?
Oh,
Okay, now we're going to look at average rate of change for 2 different lines. Can you see these 2 different lines going on here? You have this red one, which yours is all one color, I think. And then we have this blue one here. Black, whatever, they're all kind of black. Okay, so we're looking at those rates of change, and we're going from, it says the year 2004 to 2009. Okay, so the first one that we're looking at is digital music. It says we're looking for both digital music and ebooks. So I'm going to put digital music here, and I'm going to put ebooks over here. And we're going to look at the rate of change. The rate of change. We're going from 2009 to 2004 to 2009. How many years is that? So it's kind of like what we did up here, like 2, 3, 3, and 4. Those are how many minutes? We're going from 2009 or 2004 to 2009. So 2009 minus 2004 is 5 years, yeah? That's kind of what we're doing on the bottom. You guys did it mentally probably. 2009 minus 2004 is 5 years, yeah? Okay? But let's look for digital music. Here is the value at 2009. Do you see this guy right here? Okay? That is a value of 3,100. But it's in millions of dollars. So it's really like 3,100,000,000, yeah? 3.1 million. Okay? Versus down here, it started in 2004 at what? What was the starting value?
0.9.
I think that's the bottom one. 200 is the top one. 9.6 is for this bottom line right here.
So start at 200.
200, okay? So we have 3,100 minus 200. And that tells me how many I've gone up. Okay? So 3,100 minus 200 is how much?
2009 minus 2000.
2900 in a matter of 5 years. So on average per year, it's gone $580 million per year. If you divide those, 2,900 divided by 5 is 580. Yeah. So on average, it has gone up $580 million per year. Does that make sense?
Yes.
Okay. Now let's look for ebooks. Okay. So still the same time frame. We're still looking at 2009 versus 2004. So our bottom number is still going to be 5 at the end. But now we're going from what to what?
9.6 to 165.
Yep. So we take 165.8 and we subtract 9.6. That'll tell me how far I've gone up, right? 165.8 minus 9.6. That is something. 155 point. No, I don't know. 156.2. Check me.
156.2, yes.
156.2. Okay. And then if you divide that by 5, that is like 31.24. Check me. Somebody check that. 156.2 divided by 5. 31.24.
So you just take the two.
You take them, subtract them, and then you divide by the number of years that have elapsed. Yeah? Okay, so this means that it's gone up on average $31.24 million per year, right? Okay?
Wait, so we divide by the number that there is?
We divide by 5 because that's how many years have elapsed between these 2 points right here. This point and this point, 5 years have elapsed. So if we're looking at the increase divided by 5 is how many per year it's gone up. Okay? All right, that makes sense. Which one is the flatter line?
What is called?
The 31.24. So it should have a smaller slope, right? It shouldn't be going up by as many.
So that was
Does it
for
make sense?
what, audiobooks?
That was for ebooks. Ebooks is going to be smaller than digital music because it's a flatter line, yeah?
Okay, so
Okay? All right, now, you didn't realize that we did this, but the way of finding slope has a formula right here. Circle this because this is one of the very most important things that we're going to learn today. y2 minus y1, x2 minus x1. Do you remember that from Algebra 2?
yes.
Yes. Maybe, or Algebra 1, I mean.
Yes.
y2 minus y1 over x2 minus x1. Did you know that you did that up above here?
Yes.
y2 minus y1, x2 minus x1. You did it up here. y2 minus y1, x2 minus x1. Yeah? You did that up there exactly. Okay?
What were the numbers though? 1658?
What?
For the pink, what were the
Oh, 165.8 and 9.6. I just wrote over top of them.
0.8 minus what?
9.6.
9.6 over
2009 divided by, or minus 2004. Okay? So y2 minus y1, x2 minus x1. Make sure the y is going on the top. All right. They want us to use these 2 points right here to find the slope using that same formula, okay? So, do you guys remember what variable we use for slope? I almost said it just now. M. M is what we use, okay? So, we have to find the M or find the slope. These are my 2 points. Just wait, we'll get to that. We're not to that yet. Here's my 2 points. This is my x1 and y1 because that's the first set. This is my x2 and my y2 because that's my second set. Does that make sense? Just wait, we'll get to that. We're not doing mx plus b yet. We're just trying to find m. We're baby stepping it. We're just trying to find m. Y equals mx plus b. We're not to that yet. Just wait. That's the next side. Okay?
Isn't like extra?
So we're trying to find y2 minus y1. What's your y2 variable? Or what's your y2 value?
What's that called?
5 minus y1,
Quadratic equations are fun.
3. 5 minus 3. Okay? Over 2 minus negative 4. Right? 2 minus a negative 4. What happens when you have minus a negative?
You're
It
adding
becomes
up
plus. Yes, exactly. 5 minus 3 will be 2. 2 plus 4 is 6. So the slope is 1/3 if you reduce. Exactly. Okay, we remember doing this? y2 minus y1, x2 minus x1. Label them like this if you need to. Label them and write them out.
Can you scroll up
Okay.
just a little bit?
No.
31 point.
2, 4.
I think quadratic equations are pretty fun.
We're not to, that's
Wait,
next
so
chapter.
then what do we
Just
do
wait.
with the two numbers
That's light.
What?
on that line? We just say that
I learned how to
the
do it in my
equals
head last year, dude.
one more?
Oh my god.
Yes. Well, the digital music went up at a faster pace. Right. Okay, example 4. Find the slope of the line shown at the right. Okay, so we've got this line here. And we can certainly find 2 points on that line and do the y2 minus y1, x2 minus x1.
Ew.
Okay, but there may be a better way. So let's do this. Let's look at this line and let's find 2 points that cross really nicely. You know what I mean by really nicely? Cross at a very good place, right? Where is a really nice place where it crosses? Give me a point. -2, comma 0. You see that point right there? Okay, let's mark him. Where else?
0, 3, -3.
0, -3. That's a really good spot. Okay. Then, using those 2 points, we could plug them into the y2 minus y1, x2 minus x1. Or we can just look at the rise over the run, right? M is rise over run. And since I already have it mapped out, I can just look at rise over run. Now, one thing that I note, this slope has to be what? This slope has to be negative because it's going downhill, right? Downhill from left to right, it has to be negative, right? Okay, so rise over run. So looking at the left point to the right point, how much is it rising? It's actually going down, which means it's rising negative.
-4 and then 2.
-3, and it's running 2. So what's the slope? -3 over 2. Okay? If we would have put it into the formula that we just did above, we would have gotten the same answer. But -3 over 2 is the rise over the run, right? It's going down 3 and over 2. Make sense? My slope has to be negative. Happy with that?
Yeah.
How hard was that?
Difficult
Difficult?
to know extremes.
You don't
between
understand that?
that?
No? The just the graph on the last one? Yeah? So we picked this point right here and this point right here that crosses really nice. Okay? We start with the left point and we're going to the right point and we're just looking at up and down. So we said going from this point to this point, if we make it into like a kind of a triangle, right? It would have to go down 3 units and over 2 units. So the rise would be a -3 and the run would be a +2. We're going down 3 and over 2. Does that make sense?
Yeah.
And then that would just be my slope.
But if
Make
it was
sense?
running the two the
Does
other
that
way-
help a little bit?
Can go
If
that
you
way?
want to, you can certainly just take these guys and put them into the y2 minus y1, x2 minus x1. That's fine
Okay.
too. Yeah, what?
If we go the other way with the
You go
two,
that way.
would it be -2? Like if the line was going that way,
So if we went did this way,
and then yeah, like
so in that case it would
you
be
went over like that way instead of that way. It'd be -2.
yes, right. Yep. Okay, happy with that? How was that?
Hang on.
All right. Okay, let's go to the back side. Writing linear equations. We said a linear equation looks like a
Linear equation.
line. It looks like a line if I graph it, right? We've been dealing with lines, okay? Now, standard form of a linear equation is slope-intercept form, which you guys already said is y equals mx plus b. Okay. For a linear function, slope-intercept form. Slope-intercept form. Okay, they got really original with slope-intercept form. Why do they call it slope-intercept form? M is the slope, and B is the y-intercept. So it is literally slope-intercept form. Yeah?
Hang on.
Slope and then the intercept, M and B. So when we're writing this function, all we have to figure out is what is the M and what is the B, and put those numbers in, and then we're done. That's all we have to do. That's all we have to do is those two things. Find M, find B, and you're done. Good?
Wham bam.
Yes?
Sure.
Happy with that? Okay, let's do some problems here where we're finding M and we're finding B. Okay? Write an equation in slope-intercept form for the line. That's example 5. Slope-intercept form, y equals mx plus b. We have to find what m is, we have to find what b is. So let's do that. M is whatever, b is whatever. Okay? We're going to practice again that slope thing that we just got done doing. M is the slope, it's the rise over the run. Rise over run. Okay, so we're going to go over here to this line and we're going to figure out what the rise over the run is. They have a point right here and they have a point right here plotted out for us really nicely. We're going to start from the left and go to the right. And Romeo says we're going down 1. Do you agree that it's down 1?
Yeah.
Down 1, and we're going to the right 4, I think. Count again, 4. Is it 4? So what's the slope going to be? The rise over the run?
Negative 1 over 4.
Negative 1 over 4. We're going down 1 over 4. Negative 1 over 4. Okay, rather than putting the negative on top, I put the negative off to the side. So negative 1 over 4 is the M, yeah? Then the B is the what? The y-intercept. Do you see the y-axis right here?
To be 0.
Nope. Where is it intersecting that y-axis? Where is it hitting?
Negative 1.
Negative 2.
Negative 2 right here. Do you see where it's hitting negative 2? Here's the x-axis. It's down 2, right? So the B is negative 2. Okay? Now, all we have to do is put it together. So, write out this equation. Y equals, I plug the number in for M. Negative 1/4 x. And then plus B. But B is negative.
Minus 2.
So we just say minus 2, and that's what he looks like. Okay? Easy enough? Was that okay? Find the M, find the B. Done. Write out the equation. Good?
Yes.
Have you done this before, Jonas?
No.
No?
I don't think so.
No? Have you done this before, Amit?
Yeah, but I don't remember.
You don't remember? Okay, that's okay.
We did parts, but yeah.
Okay. All right, the next one, this thing is called, there's a typo right here. This is called point slope form. Okay? You can go ahead and write that in there if you want to, but I don't like point slope form. I don't like it.
Why?
And you don't get tested over it very much. Like, it doesn't appear on like the ACT tests and stuff. It's always going to be slope intercept form. So I'm going to change the instructions of your homework assignment. Anytime it says write it in point slope form, you're going to do it in slope intercept form. One thing to remember, you don't have to remember a different way of doing it. Everything's going to be in slope intercept form, not point slope form. You can just cross it out. Okay, but we're going to do the examples, so don't cross out example 6, right? Next thing, write an equation of a line through the point 6, negative 2 with a slope of negative 4, okay? There are 2 things that I need for an equation, and they are, right, what are the 2 things that I need to plug stuff in for? M and B, okay? Do they give me M and B?
No.
They give me 6, negative 2 with a slope of negative 4. What do they give me?
The slope.
They give me the slope, which is
M.
M, which is negative 4. That's what they give me. Okay? Half of my job is already done, right? I have y equals negative 4x plus b, right? They don't give me b though, right? That's the only thing that I have to find. They don't give me b. You see where we're at right now? Are we okay? How can I use 6, negative 2 to find what b is? How can I use 6, negative 2 to find what b is? 6, negative 2 stands for x and y, right? That's an xy coordinate point, right?
Just go up on the graph.
So then what do I do with x and y? What?
Go down the slope of negative.
Nah, I don't want to think about it. I don't want to have to think.
What's the point of that?
6 is x, negative 2 is y.
Plug in 6 and negative
Plug in 6 for x and plug in negative 2 for y. You betcha. Make sense? Plug in 6 for x, negative 2 for y. What? Like that. Okay, 6 for x, negative 2 for y. So I have negative 2 equals, what's negative 4 times 6? Negative 24 plus b. Okay, from there, I gotta get b by itself. Add the 24, you betcha. Okay, so what's negative 2 plus 24? B is 22. Am I done?
Well, you have to rewrite it out.
You have to rewrite it out, right? Y equals, what was the slope again?
Negative 4.
Negative 4x
Teachers, please dismiss the junior high football players.
Plus 22.
plus 22. There's the equation that I need, yeah? No. Sorry. We're almost done. Negative 4x plus 22. Good? Okay, next, 7. Write an equation of the line passing through each pair of points. Okay, so starting with A. Can I zoom in?
Not quite there yet. I'm sorry.
Okay.
This B plus 24.
Example 7 says write an equation of a line. So we
Okay,
want to
I'm
get
good.
to y
I'm good.
equals mx plus b. What are the two things that I need? What are the two things that you need?
Slope and y-intercept.
You need the m and you need the b, right? Do I have either of those if they give me these 2 points?
No.
No. What do you find first, the m or the b?
The m.
The m. How do you find the m if you're given those 2 points?
Y2 minus y1 and x squared minus
y2 minus y1 over x2 minus x1. Okay, what's your second y coordinate? If you need to label them, do this.
3.
x1, y1, x2, y2. If you need to label them, you can.
Negative 3.
Okay?
So,
So-
it'd be -2.
Negative 3 minus
-3 minus
7 over
3 minus
Over 3 minus.
3 minus a
Plus-
negative 2.
which is
So it's really just plus. Okay? What's negative 3 minus 7?
-10 over 5.
Negative 10 over 5, which is
-2.
-2. So I found the m. Great. Now how do we find b?
Plug it in and use
Okay.
the x.
We have y equals negative 2x plus b, because that's what the m is, right? Okay. Now how do I find b?
you can plug in one of the coordinates.
Now which one do you plug in?
The first one.
Second one.
Whatever one you want.
Whatever one you want. Does it matter?
Uh-uh.
No.
Second one is easy.
Do you want to plug in the second one?
The junior high locker rooms will be used tonight. If you want your stuff locked up, you need to make sure you do so before 4:30 today. The junior high locker rooms will be used tonight.
It's sophomores and up in the high school.
All right. So, one thing that I will add to this: when you're plugging stuff in, make sure that you're plugging this guy in for the x and this guy in for the y. Right? I have a lot of people that will put them in that order going down here because this is the first one, that's the second one. You have to kind of crisscross them. Does that make sense?
Yep.
You have to crisscross them. So, negative 3 is the y and positive 3 is the x. Okay? So, negative 3 is equal to, what's negative 2 times 3?
Negative 6.
Negative 6 plus b. And then we add the 6, right?
And it should be
b is
3.
3. Okay? Almost done. Y equals, m
So
was,
B equals 3. Negative 2.
yep, b equals 3. Y equals negative 2x plus 3. Okay, happy with that? Am I going through this too fast?
I understand.
Yeah, you're doing okay? Yeah? Okay, B, part B. We have
Same
4,
thing.
negative 7, and 4, 6. So we're going to find the slope, m. What's your second y coordinate?
6.
6 minus?
No, plus 7.
Yeah, minus a negative 7, so she says plus 7 over,
4 minus 4.
uh-oh. We have 13 over 0. What is 13 divided by 0?
0.
It's not 0.
13.
0,
One.
0 divided by 13 would be 0. What's 13 divided by 0?
You can't divide by 0.
It's undefined. You can't, friends don't let friends divide by 0.
So it's undefined.
Friends don't let friends divide by 0.
Undefined.
It's undefined.
Oh, 13 over 1 equals 13.
Yep, right. It's undefined. Okay, so
Sure.
rather than doing it this way, I'm going to kind of sketch what these two guys look like. Okay? I'm gonna go down my. Oh, let me. Hold on. Let me. I'll get. I don't know what it's.
Well, because it's not Friday, so.
Rather than trying to write the equation out, let's graph the 2 points, okay? So 4, -7 would be down over here, right? Yeah, agreed?
Yeah.
And then 4, 6 would be somewhere up here, right?
Yeah.
What's that line gonna look like?
It's just a straight line.
Straight line up and down, right? Okay? Do you know what that equation of that line looks like?
Wait, why is it?
It's gonna be straight up and down. Between 4, 6 and 4, -7.
The slope was zero.
It has a slope that's undefined. Slope of 0 would be a horizontal line, okay? Do you know what that thing looks like as an equation? It's not y, it's kind of like y equals mx plus b, but a little bit different.
Nope.
What axis is it cutting through?
The y-axis.
No. What axis is it cutting through? It's
Yeah.
cutting through x. It's cutting through this guy, right? No matter what, the x coordinate is 4. No matter what, the x coordinate is 4. You see that? The y coordinate is 6. The y coordinate is -7. No matter what, the x coordinate is 4.
If you wanna vote for homecoming royalty, you need to do so before tomorrow at noon.
Okay, happy with that? Make sense? X is always 4. The y coordinate doesn't matter. It's 6, it's 7, it could be -14, it could be -173. The y coordinate, or the x coordinate's always 4. Yeah? Okay, last thing is parallel versus perpendicular.
So what do we write for M and B, or do we just leave it as
It's x equals 4, that's it. There is no m and b. M is undefined. So we don't have a piece for m. So that one's kind of a weird one. Okay? Alright, parallel lines versus perpendicular lines. Did you know what parallel lines look like?
Yes.
Straight up
These
and
two
down.
guys right here. Looking at these two equations, what do you notice about parallel lines?
2x.
Two
They're the
X.
same.
They both have the same
Slope.
slope, right? If this guy's going up 2 over 1, up 2 over 1, this guy better do that also, otherwise they're going to run into each other, right? And we already said that they're parallel. So they have to have the same slope. Same slope. Okay? Now these two guys are perpendicular,
which means it intersects.
which means they intersect. They go like this, but they don't just intersect, they make a special thing when they intersect. They make a perfect corner, a perfect 90 degree when they intersect, okay? Look at those two slopes. We have 3 and we have -1/3.
So it's just gonna be -1 over.
It's the negative reciprocal. Negative reciprocal slope. The slope is a negative reciprocal. Negative reciprocal. Okay, so let's say the slope is 2/3. What will my new slope be? 3 over 2, but
Negative.
negative. Okay, let's say the slope is -1 over 7.
It'd be positive subset.
It'd be +7 over 1 or just +7. Does that make sense? You flip it. Okay, good? All right, let's do this thing here, and then we'll be done. Whew. Are we ready? Are we doing okay? Have I snowed you yet? Not too bad? Yes? Okay, all right. All right, to write an equation in slope-intercept form of the line that passes through 5, -6, circle that, and is perpendicular. We're going to do both parallel and perpendicular, so you're fully prepared for your homework assignment. Parallel and perpendicular. And I want it to be parallel and perpendicular to this line. Okay, this is my original line. Okay, what is the slope of that original line? -3 over 2. So if I want a line that's parallel to it, that slope has to be
The same.
the same, right? Okay, if I want a line that's perpendicular to that, what does his slope have to be?
The opposite. So
-2 over 3.
+2 over 3, right? It's already negative, so we make it positive. +2 over 3, yeah? Okay, and then I just start. So I know that I have -3 over 2x plus what?
Anything.
We have to find the b, right?
Oh yeah.
So I'm going to put just plus b. This 7 that's up here, do you see the 7 right here?
Yeah.
You cross it off and you never, ever, ever use it. The only reason you use this original one is to get its slope. Don't use the 7 ever, ever, ever. Ever, ever. Okay? Good? Now, how do I find the b down here?
Plug something